Hello my friends, HM here. In this video I'm going to talk about the Shahed suicide drone and why it has the potential to win the war for either Ukraine or Russia. The reason this drone can win the war is that it's possible to manufacture it by the tens of thousands per month at very low cost. At that scale, it'll be able to overwhelm any known air defense systems, even all the air defense systems that Russia or NATO currently got to shoot it down. So at that scale, there'll not be any effective defense against that weapon. I have organized the video using a PowerPoint presentation that contains all the material that I collected during the research for this video. I've also made an Excel spreadsheet that sums up the cost of making this drone, both when it's hand-built in a composite version and when it's mass-produced in a metal version. If you like, there's a link below this video where you can download both the presentation and the spreadsheet, and that link will be available at hmexperience.dk. However, before we start, I'd like to say that HM Experience is a video blog that focuses on anything that matters for whether the future of humanity will be better or worse. Today's video matters for that future because if Ukraine wins, it means the people of Ukraine can live in freedom rather than tyranny. A Ukraine win will also show the world that military aggression to steal people and land will not pay off, and therefore we will have less war in the future. With that said, let's get to it. So the title of my presentation is that if a Nobel Prize was awarded for best weapon in 2022, the Shahed 136 would get it. So let's get to the next slide here. The weapon that could determine the war. It really is. The weapon in mind is not the US-made HIMARS rocket launcher, but it's the Iranian-made Shahed 136 long-range suicide drone. That drone was made by the Iranian company HESA and officially entered service in the Iranian army in December 2021. Its main advantage is low price and simplicity. It can be mass-produced by any industrialized country using simple components that are easily acquired, even if that country is heavily sanctioned. And that's kind of why Iran has made it, because they are heavily sanctioned. It's also a weapon that Russia can make, even if they are heavily sanctioned as they are. This presentation will take a closer look at this weapon and its capabilities. That's what we'll do first. Then secondly, we'll discuss manufacturing costs and design features. And thirdly, we'll discuss what can be done to effectively defend against this drone weapon. And finally, I have some humble advice to Ukraine and NATO about how to deal with this forthcoming new capability of Russia to bombard Ukraine. Because the fact is, Russia is planning to mass produce this weapon in Russia. And they'll make a lot more than Iran currently make. Could be tens of thousands per month. But let's talk about it. Let's first take a look at it, how it looks. This is the weapon. So there are 5 of them here, and also I have some pictures up here in the side that shows it. Well, I'll have better pictures of it later on in the presentation. Let's first go to the specifications for this weapon. As I mentioned, this is an Iranian company, HESA, that made this weapon, and it officially entered service in the Iranian army in December 2021. The weight of this weapon is 200 kilos. It has a warhead with 40 to 50 kilo of high explosives. HIMARS warhead, HIMARS, the very successful missile launcher system that Ukraine has used against Russia, has a warhead that is 120 kilo and the rocket itself is 300 kilo, just for comparison. The size of this drone is 3.5 meters long and it has a wingspan of 2.5 meters wide. The HIMARS rocket is 22 or 23 centimeters wide and it's almost 4 meters long. Cruising speed of this drone is 185 kilometers per hour. That's very low, but that's also why it can be made so cheaply. It doesn't have a rocket propulsion system that would make it a lot more expensive to make. The HIMARS speed publicly unknown, but likely it's over 1,000 kilometers per hour. Range of this drone here is 1,000 kilometer, and there has been claims it can even go 2,500 kilometers, but that's definitely with a much smaller warhead. Otherwise, it won't be able to do that. But 1,000 kilometers, that's probably right. And HIMARS range, for comparison, is only 70 kilometers for the version Ukraine got. HIMARS also come with some rockets with longer range, but for some insane reason, US have not provided that to Ukraine, although it would help Ukraine a lot if they could hit Russian targets at a longer distance. But if Ukraine got this weapon, they'd be able to hit anything in Russia west of the Ural Mountains. And also they'll be able to hit anything in Ukraine that Russia has occupied, like Crimea. Okay, the flight height for this drone is 60 to 4,000 meters up. And I'll talk a little bit why the 4,000 meters flight height is actually very important, but I'll talk about that later. And the unit cost, it's unknown, but various sources say that it's about between $10,000 US and $60,000 US, which is insanely low, especially for such a long-range weapon. Current Iranian monthly production capacity has been said to be about 150 units, which is probably true. Russia has ordered about 2,000 of them, and it will take some time for Iran to deliver that many. I believe Russia got 300 immediately, and then they'll get more later on. But the thing is, Iran is hand building these, but I'll get into how these things are made now. Okay, let's move to the next slide here. That's not a very interesting slide, but it has all the sources for the information I just stated. And that's how I do my PowerPoint presentations. I put in a lot of sources for everything I say, so you can check it yourself. I have a PhD, and naming all the sources kind of a must. And I think people should do it instead of just claiming stuff and then it's all wrong. So here at least you can check it out yourself. Okay, let's go to and talk about the manufacturing cost and design of this machine here. And we start with propulsion. It's powered by it's very low tech. It's a propeller design. You can see this on this image up here. You can see there's a propeller on the back. You can barely see it, but I have some better pictures I can show you in a minute. And it uses a 50 horsepower engine that was developed originally by Volkswagen and used in the Beetles from 1936 to 2006. So it's a very old, very tested design that has served Volkswagen well for many years. And now this engine is still in production in China, has another name, and anyone could actually order this machine also recently online from various Chinese web shops. But now it has been removed, so it's no longer publicly available. Probably for political reasons, it's no longer available to order. And I'd estimate it's a $400 engine because it's a very simple engine and it doesn't have anything advanced on it. You don't need any, you could say, you don't need any emission controls or anything that's advanced that you would need in a modern vehicle today. For this drone, you just do it quick and dirty. And because it's such an old design and it's very simple, both Ukraine, Russia, and Iran could easily reverse engineer this engine and make it themselves if they wanted to. The warhead is also simple to make and it's not costly. An anti-tank mine, I looked it up, of 10 kilo with 10 kilos of high explosives only costs $40 apparently. So $200 for US dollars for the warhead, and you round that up to 500 to be on the safe side. And it also looks like the Shahed frame and body use a lot of composite materials that are low tech, but it's not suited for mass production by the tens and hundreds of thousands per year. And how do I know it's a composite material that they use? Because of these images here, Ukraine has shot down one of these Iranian drones, and some debris shows some part of it. Here you can see this Volkswagen engine that sits on the back. You can see it on this picture over here. And it also appears it sits on a gimbal. This is a gimbal system, so they have some extra control there. Then there's the propeller is attached right here. And I think this is a close-up picture of the propeller where that propeller is attached. But I'm not sure. Maybe it's a warhead and a detonator. It could also be that. I don't think so. But I think it's a propeller. And why did I know it was a composite material? Because this wingtip that has broken off here is broken off the way that composite materials would break off. It's not, if it was metal sheets, it would not break like that. It would there would be some twisted metal sheets that would indicate it was metal. And this down here, I don't know what that is. It looks like cooling ribs, so it could be an electronics control unit for this drone. But let's move on to the next slide. Okay, we move on here. So the next I want to talk about is frame and body. And in order to get to a production volume of tens or hundreds of thousands per year of this drone, it cannot be made of composite materials. It has to be made of metal sheets and a metal frame that can be produced in much the same way as an automobile is produced. With that kind of design, it could be produced like an automobile. You could get down to a cost of only about $5,000 US, including assembly cost. Not for the full drone, but just for the sheet materials and for the frame that makes up the drone. But that would require, we are at 10,000 monthly rate. And I don't have a source for that cost, but you can make a cheap vehicle body in the automotive industry that is 5 times more heavy. It would be a ton instead of 200 kilo, and structurally more complex for the same price, also about $5,000 US. You know, the least expensive Chinese or Indian cars, they don't spend more than $5,000 on making the frame and body of their vehicles. Definitely not. And it's more advanced than this drone. The Iranian drone that's currently produced of the Shahed here, that's set to be made in about 150 units per month. And it is composite body and frame. And I'd estimate that to cost about $50,000 just for that body and frame, because it's composite. And it's also a slow manufacturing process. There's a lot of handmade things that goes into making something of a composite. But a metal drone would of course have one drawback. It would weigh more than a composite frame and body. So there would be a toll on the possible range with this drone, but it's already so high, 1,000 kilometers was possible with a composite frame. And you'd probably be able to do it with a metal frame and then still keep 600 kilometers range. Here it should be mentioned that, Iran has some special needs. Their arch enemy is Israel. And in order to hit Israel with these drones, they want them to be able to fly all the way to Israel from Iran. So that's why they probably didn't have any option but to make them of composite materials if they wanted to hit that specification that it should be able to hit Israel. Now, Ukraine doesn't have that need to go that far. So 600 kilometers would be fine for a Ukraine version of this drone. And then the other thing you could say is, well, if it's made of metal and not composite materials, it would have a much larger radar signature, so it'd be easier to spot on the radar and be more easy to shoot it down. My take on this is that because of this engine that sits right there on the back wide open, it already has a big radar signature, so it doesn't really matter. And the other thing is that if you can make it at that low cost, which I am sure you can make it at really low cost, then it doesn't matter that that you can shoot it down with a $100,000 or a $3 million missile. If you only spent less than $10,000 on this drone, you just send another drone and another and another. Just keep sending them. It's actually a gain if it's shot down with a expensive air defense missile. But let's move on. So let's consider the takeoff mechanism. It has a brilliant design feature here, the Shahed drone, because it uses an expendable rocket. And my guess is it uses a cheap solid state or solid propellant rocket, which is basically the same thing as a New Year's rocket. It's just much more powerful. And you could probably make that for $300. It saves cost to use this rocket because then you don't need a much more complicated landing and takeoff gear for this drone. It also obviously saves weight. If you don't have to have this landing and takeoff gear, then you save a lot of weight, and that also increases the range. Less weight means more range for this drone. And more weight is saved because the drone can gain altitude and also obtain max speed with that takeoff rocket there. And a lot of fuel is used to gain altitude and also speed. So that's a good way to get the drone started and also save a lot of fuel and weight and make it even more longer range. But with that said, if I was going to deploy this drone in my army at large scale, I'll build a system that would use a catapult launcher instead of a rocket. That would be similar to what a Navy aircraft carrier has, but instead that's steam powered. But I would just use for this drone here, just use an electric motor that wind up a pull cable. Will be far simpler and cost not much to launch this rocket. And I would also try to make it a portable system that could be packed all into one standard shipping container and set up anywhere in like say 1 day or less than a day for a crew of say 4 soldiers. And also I would decrease the wingspan of this Shahed drone. It's 2.5 meters wide, but that means it cannot be stuffed into a standard shipping container. So I'd decrease it to 2.38 meters. So it actually could fit a standard shipping container that's 2.43 meters wide. And if you did that, you could actually fit 12 of these drones into a 40 feet standard shipping container. And you could set up a catapult system, and then you could launch 12 of these within, you would probably launch them within an hour with a lift crane that simply lifts them up from a cradle. You take them first out of the container using a standard equipment. What is it called? A gaffel truck that simply takes packages out of containers, and then you open them, prepare them, line them up, and then you use a small crane to lift them up on the catapult that then launches them. And you can launch them, because it has such a long range, you can launch them far behind enemy lines, so artillery, counter-artillery cannot reach you. So you'd have an hour to launch 12 from one system. Okay, here I have some pictures that shows much better how the Iranians have solved this takeoff problem for their drone. So you can see they have a truck that has loaded 5 of these drones into it, and then they can fire it directly from this truck. Here, if you look close on the on this picture, you can see this rocket that I talked about. It sits below the drone here. It's a black metal thing here, and I'm pretty sure that's a launch rocket. And you can see it on all 5 of them. And then here we have a better picture how it actually takes off, flies out here. You can see the exhaust from this rocket. And so that's how that's done. And here is a picture, close up, same as this one over here, just blown up. You can see how there's a mechanism here that holds this solid propellant rocket. That's a kind of the mechanism where it's attached and how it is then dumped a few seconds after it has been fired and accelerated this drone into the air to probably full speed at 185 kilometers per hour. And also, I don't know, 100 meters up. I don't know how long it can get it up. But that's how it looks. Next, let's talk a little bit about the aerodynamics of this airplane. It's another brilliant design feature of this Shahed drone is that it uses a cropped delta wing design. You can see it's cropped on this picture here with because it's cut off at the wingtips are cut off. And in my opinion, this cropped design with a pendicular flap, that's the one you can see here on the side of the wing, solve this problem of flow separation at high angles of attack at low speed. What is that? When the drone flies, let's say this hand here is the drone, and here we have the wind, and it's going in that direction. In order to create uplift, and because it has low speed, it has to increase its angle on the wind flow in order to create that uplift. And that's a problem because when you increase the angle of attack here, you create turbulences down here at the end of the drone, and that will give a drag to the drone, and that will dramatically decrease the range of the drone. So how do they solve this aerodynamic problem? Well, they group the delta wing and they put this perpendicular flap on. I'm pretty sure that the Iranians have tested all kind of versions, and that particular shape there will solve that flow separation problem. So that was my little take on that. And then the delta wing itself is a great design because it's known to be one of the most efficient designs that are possible. It's more efficient than a traditional airplane, that uses a big fuselage with wings in the middle and then flight control wings at the back. We all know how a traditional airplane look like. And you could then say, why are we not using delta wings if they're so efficient and they're so great? Why wouldn't we use them on traditional airplanes? Because a traditional airplane design is used because we need the big fuselage to accommodate passengers and cargo. And it's also a more weather robust design. If there's a lot of turbulence or something happens to the airplane, it loses an engine or something, then it's more stable and it's easier to control than with this delta wing design that's more efficient, fuel efficient. But the delta wing design is obviously the best choice for making a long-range, affordable suicide drone like the Iranians have done here, because it obviously do not need a large fuselage. And also robustness, safety of flight is not a big issue either. It's a weapon, it's a suicide drone. It's going to be destroyed every single time it's used. So it's not like a commercial airliner that has to function again and again and again without any errors. This one, it's a suicide drone. It doesn't matter if it crashes one in 100 times. Whereas that would be a big problem for commercial airliners. Okay, the next thing I'm going to talk about is controls. How do we control this airplane here? And we can see here's a picture of 5 of these drones. And From the picture below, it's kind of easy to see that the drone uses 4 actuators to move the 4 control flaps at the back of the delta wing. You can see these control flaps here, 1, 2, 3, 4, and you can see the arm that sticks out there. That's an actuator that can move this control flap up and down. And these control actuators, I think they cost $30 each. It's just to have more estimates of what this drone cost to make. There's one more thing here I think is important for how this aircraft is controlled, and that is that I'll put up some pictures here. I think from these pictures, we can conclude that this engine here that sits on the back and with this propeller on, it's also mounted to a gimbal. And here we can see the gimbal system, and we can also see there's some space here from that means that this whole engine can actually move around. That's what this gimbal does. It can move the entire engine up and down and back and forward, so that the propeller itself and which direction it propels the aircraft forward can be controlled. So that's how I think that's kind of the complete picture for how this drone is controlling itself. It has these 4 flaps, and then it has a gimbal on the engine here that can be move the entire engine with the propeller around. And that's how they control it, because I would be a little skeptical about controlling this airplane with just 4 flaps. I'd say that would be pretty hard. Also, what if this engine is just not completely correctly put on, so it doesn't blow air back in the exact right proportion? Could you compensate for that with just 4 flaps? Well, if it's on a gimbal, it's easy. Then the control computer of this drone can easily make a little adjustment and have the drone fly in a stable way. So that's just my take on that. I may add that I think that gimbal system cost about $200 to make. So this value here, $200, that would be a gimbal for this drone. The final production or manufacturing cost and design part I want to talk about is navigation, because that's a third great design feature of the Shahed drone here. It has dead simple navigation that's based on a combination of publicly available satellite navigation signals and also inertial navigation. Currently, there are 4 global satellite navigation systems available. The US, that's called GPS, the EU system, that's called Galileo, and then there's a Russian one called GLONASS, and a China system called BeiDou. And all of these signals are publicly available and can be used by this drone if it has a satellite navigation chip built in, and it has. And if that satellite signal or all of these satellite signals are jammed, then the drone can still find its target using inertial navigation that uses motion sensors, that's accelerometers and rotation sensors, gyroscopes, and a computer to calculate its new position given the last known satellite position and subsequent movement of the drone that can be registered by these motion sensors. So that is what inertial navigation is about. And also, to improve precision, these inertial sensors could be supplemented by a barometric altimeter and or speed measurement devices. I don't know whether the Shahed drone has any supplementary sensors, but it might just have this satellite navigation and then inertial navigation. I haven't been able to find any sources on the internet that describes that in detail. And also, I don't know how precise this Shahed drone is. Only the Iranians and Russians probably know that for certain. But I would say it's not far off to say that it would be able to hit its target with plus minus 4 meters if it has a satellite signal, because publicly available satellite signals are definitely giving that kind of precision or making that kind of precision public. And if you have a military version of the signal, which now is confirmed that Russia has the redesign they're doing with this drone. They will, of course, use the Russian system and for satellite navigation, and they can put even more precision into it, so it will only be 1 meter or less than a meter accurately with that kind of signals. And if it's jammed and the signal is jammed, then I'd say it's probably the precision of this drone is dropping to plus minus 40 meters. And that's based on a guess from me that might be totally off, that it has lost its satellite signals 30 kilometers from its target. It will still be able to hit the target with plus minus 40 meters precision. It could be wrong because I don't really know, but these inertial sensors or inertial navigation is quite accurate actually. And it's also used by Iran. Is not the only one using that. All Western weapons have inertial navigation built in so that the target can be acquired even when a GPS signal is lost. That's quite standard. And the crazy thing about this navigation system is that it probably costs less than $50 to get the needed computer, the satellite navigation chip, and the motion sensors. They are dirt cheap if you can buy them, but it's still high tech. So if you're under sanctions, you can't order them directly from the factory, but you can find these free sensors or the chip, the satellite sensor and the motion sensors. You can find all of that in a traditional smartphone. So you just rip open a smartphone and take out these components and then use them in this drone. So I don't think any amount of sanctions can prevent Russia or Iran from mass producing this weapon. They will still have access to what they need in order to make their navigation system work. I may add here that you don't need the latest and greatest in iPhone chips in order to run the computer for navigation of this drone here. You can use a very old smartphone chip for that you can have for, say, $30 if you could buy it directly from the manufacturer. And the satellite navigation chip would probably be, I don't know, $10, and another $10 for the motion sensors if you can buy them directly at large volume from the manufacturers. And if you can't, just rip open an old smartphone and you can get it from there. An old smartphone will not have the latest GPS chips, so you probably need a new smartphone for that. Okay, so let's make some conclusions here. The previous slides here estimated the cost of making this Shahed, and I talked about different various components where given a cost estimate for that. And if you sum it up, you'll see that a hand-built composite version that Iran built cost approximately $53,000 per unit, and they make 150 of those per month. And you'll also see that a mass-produced metal version that I suggested that any industrialized country could build would cost only about $8,000, but that presumes that you're making at least 10,000 units per month. Note that if you do build 10,000 units per month, that would be 120,000 of these drones per year. It would cost 120,000 drones per year would cost less than $1 billion. That's an insanely low amount of money, and both Russia and Iran and Ukraine can afford that. Any country of just a little bit of size can afford putting that much production up for a weapon that will be very capable and that can overwhelm any known air defenses against it, if you have that many to send. Okay, and I have a spreadsheet that you can download at hmexperience.dk that shows in detail how these costs are added up, and also shows how much, a few calculations of how much it would cost to make 120,000 of them and even larger numbers of them. Then we know here, I read that Russia has gotten the blueprints here in November 2022 for this Shahed drone, And now they're setting up their own production of this drone. And it's unknown how big a production capacity Russia is aiming for, but they could definitely make 10,000 units per month, and it's doable within a rather short time, say 14 months to full production at 10,000 units per month. But of course, Russia can do it, and Ukraine can also do it. Okay, here we just have some sources for what I said in the previous slides. Now let's talk about the defenses for the Shahed drone. The reason that the Shahed would win the Weapons Nobel Prize in 2022, if such a prize existed, is that there are really no good defenses currently against 10,000 Shahed drones per month. We have very good defenses for just a few of them, but for 10,000 per month, it's a huge problem. Also, the Shahed's flight height is 4,000 meters, and at that altitude, most anti-aircraft guns and most short-range anti-aircraft missiles can't reach it. They're below that height. So that means that you have to use a mid-range to long-range anti-aircraft missile. And such a missile start at $200,000 US dollars each, and they go all the up to $3 million US dollars each. The Patriot anti-aircraft missile system that NATO uses, their missiles cost $3 million each. $3 million. They can shoot down anything really, but at $3 million a piece, it would be a great triumph if it needs to be spent on shooting down an $8,000 drone. And even if the entire stock of NATO's mid to long range anti-aircraft missile systems was used up, all of that stock would have been gone after you have sent 30,000 of these drones in just 3 months of attack against, say, Ukraine. And Ukraine got everything NATO has on stock in anti-aircraft missiles. Also, how many new anti-aircraft missiles can NATO produce? We probably only have production capacity to make 500 new long-range to mid-range anti-aircraft missiles per month. So that's a far cry from trying to stop 10,000 of these drones per month. So the problem is that current defenses for this drone, they're too limited and they're way too expensive. I found a graph here that was provided by, I think, a minister of defense or something from Ukraine. There's here's the source. It's somebody in the Ukrainian administration who lists all the missiles that Russia has and how much they have used up of them and how many new ones they have produced. But there's one interesting, these are all attack missiles, ground to ground. But there's one here, the S-300. That's the main anti-aircraft missile that Russia has, but it can also be reprogrammed to function as a ground-to-ground missile, and that's why they have included it in this table. But you see here, Russia had 8,000 of these S-300 long-range anti-aircraft missiles, and they would use that arsenal up very quickly, and that's pretty much what they got. Then they have a little bit of S-400 missiles. I don't know, I think they have less than 1,000 of those. So just 1 month of attacking Russia or Russian occupied territory in Ukraine, and Russia would run out of defense weapons for defending against a Shahed drone that Ukraine was using against Russia. But the same can be said about, Russia sending these drones into Ukraine with that kind of intensity. Ukraine would not be able to defend against it after a few months, even if they got everything NATO have on stock. So there are some alternative defenses against the Shahed. For instance, another way to defend against it is to jam all satellite navigation signals. So the drone will hit the target with less precision and therefore do much less damage. And the longer the drone is without a satellite signal before it reaches the target, the less accurate the target. So this defense will of course also destroy all satellite navigation around the cities and military positions you want to protect with this jamming equipment. I don't know how much jamming equipment Ukraine has, but Ukraine is a big country, and I don't think they have enough jamming equipment to jam every area of Ukraine. But I think right now they are getting a lot more of that equipment from NATO because, you know, they are bombarded with long-range weapons from Russia all the time now, and Russia have also started to target civilian infrastructure like water supply and electricity supply. So they are getting more defenses, Ukraine, but it won't be enough to protect against this Shahed drone if it's made by 10,000 per month. The Shahed drone here has one, you could say, weakness. It's its low speed, 185 kilometers per hour. So another possibility is to use helicopters and airplanes equipped with machine guns and then shoot them down. That's a possibility, and it's also fairly low cost. But of course, if you attack with 333, that would be 10,000 drones per month, or 333 per day, then you'd have to have a lot of helicopters and airplanes to make an effective defense against it. And Ukraine don't have that many helicopters and airplanes, so it's not really an option for them either. But of course, in the future, things won't stay the same. Once these drones are mass-produced, there will be a reaction. And hopefully they're already working on it right now. So they're anticipating that there will be mass production of these drones. And you could make a fully automated system with radars and reusable drones with machine guns that can be sent to shoot down this Shahed. And you could also perhaps add to such a system small automated suicide drones that could also kind of simply fly into this Shahed drone, and then with a small explosive device they could blow themselves and that Shahed drone up. But that will take time to develop. And here I have some sources, of course, again from the previous sites. Okay, now we've reached the end of my presentation, and I'd like to finish it off by giving some humble advice to Ukraine and also NATO about how to proceed given this threat from this Shahed drone. I think we should expect that Russia is likely going to have some production online for the Shahed already by the second quarter in 2023. And probably only for 1,000 drones per month, which would still be quite a lot and make already a significant impact on the war. So that's a big threat. But it will get far worse because by the first quarter of 2024, I think Russia could be doing 10,000 per month. And it could even get much higher than that if they continue to expand production, because that Shahed drone is cheaper and much easier to make than automobiles. And I may add here that auto manufacturing companies in Russia has pulled out of Russia, and that means there's a lot of empty auto manufacturing factories in Russia right now. So it's kind of obvious that Russia could just start taking one of these factories and then refurbish it for making Shahed drones in mass production. And there won't be any good defenses against this Shahed until someone develops a fully automated radar drone system that can shoot it down at very low cost per kill. But such a system is almost exclusively software development projects, as the needed drones and radar tech already exist. It's just about how to control these drones and do it fully automated using some software. And it's far more likely that a NATO country will be first to develop such an effective defense system against the Shahed, simply because we have many more software engineers at the high level that it takes to develop such a complicated software program that can do this. And Russia is a small country, and although they have some really good programmers, Many of these programmers have left Russia to work for Western companies, and Russia doesn't have the capability to do an effective defense against a mass-produced Shahed drone and do that quickly. But they could probably do it with a few years delay after NATO has developed an effective system. And I don't expect, even if NATO see my video or is already working at it, that's the latter is probably the most likely case, that NATO is already at full swing doing this defense system. I still think we won't have anything up and running before 2025. And therefore, my advice to Ukraine would be that they should set up their own factory for mass production of this reverse engineered Shahed drone, and then try to do it faster and at higher scale than Russia in order to overwhelm Russian defenses. I don't think it would be a good idea for Ukraine to build this factory in somewhere in Ukraine, because Russia will find out where it is. It will be a large factory. Thousands of people will be employed, and obviously Russia has intelligence sources that can figure out where that factory is, and then they are going to send everything they got at that factory in order to destroy it, and they will destroy it. So what I would do if I was Ukraine, I would contact a really friendly NATO country, and that would be Poland or the Czech Republic. I think they're the most friendly NATO countries to Ukraine that exist. So Russia would not dare attacking this factory, then risk a full-blown war with NATO. So my favorite would be the Czech Republic, because they already got a large automaking industry, and they also have a fairly large industry for making military equipment. So I think they have an advantage over Poland. Also, if I was Ukraine, I would engage a US company called Monroe and Associates. I put some link down below to help with reverse engineering of this Shahed drone, and also help with the redesign that's needed to make it mass producible at very low cost. Full disclosure, I have zero monetary connection with Monroe and Associate, but they are the right company for this kind of job. They have done countless of reverse engineering projects on automobiles, and they also work on airplanes, and they have business experience with both private companies and also the US military that they've done some jobs for. I know this company only because they have a popular engineering YouTube channel where they disassemble products like automobiles. Most famously, they have disassembled pretty much all the Tesla vehicles, Model 3 and Model Y, and also Model S, I think. And they have bought these cars, and then they disassemble them, make a YouTube video about it. And then they also make some detailed reports that list exactly how it's done, and how much it costs to build these products, and also come with advice for how they could be made even smarter. And then anybody who's interested can buy these reports and use it to develop their own products. But that company has this YouTube channel, and has when they started it, the prime owner of Monroe Associates, he's called Sandy Monroe. He thought it was a stupid idea, but some of the younger ones wanted him to start doing it. And it has turned out that it's a great sales channel for that company to have a YouTube channel, as so many other companies has found out. And it's kind of part of why I'm doing this, my own channel here, because I have another project that I'd like to have enough people who know me about to get that up and running. And I think a YouTube channel where I talk about stuff that interests me, well, and also reveal my own personality and my own capabilities, that would be a good way for me to profile myself to the public. Anyway, that was a little sidestep. To round up, this Shahed drone is worthy of a weapons Nobel Prize if it existed, because it's by far the cheapest high precision long range weapon in existence. And everything else with similar precision and destructive power as the Shahed drone, it will start at $110,000 and it will have much shorter range. For instance, this HIMARS with only 70 kilometers range, that's a good example of that. And I think serious armies like China, Russia, Ukraine, Poland, Turkey, they will all need, and the US, they will all need hundreds of thousands or even millions of these Shahed type drones, and also acquire defense systems against them. Otherwise, they will not be able to win wars or defend themselves against enemies with these weapons. It's a game changer. This weapon is a game changer, and we are going to hear a lot more to it, especially when I think Russia or Ukraine get into full speed mass producing this weapon. Okay, that was kind of my presentation, and I only have a few final remarks to make. If you liked this video and would like to help me making more of these videos, please give it a like and perhaps also subscribe to my channel to help me get started. It's only my 4th video, and I'm struggling a little bit about making these videos, but I think I'll get better at it. And I think it's kind of fun. I've learned all kind of things I didn't know about, how to edit videos, and I hope I can also get a little better at communicating clearly when I have to make these presentations. So please support me, give it a like, and subscribe, please. So thank you very much. That will be it.